now some problems that you're going to run into. I couldn't tell you the advantages without giving you some disadvantages. This is a root. Properly managed, you'll never see this in your system. Trifluralin, there are several different labels that you can put out. If you're in a permanent crop, this one was in an alfalfa field. Every 60 days, trifluralin, an ounce to the acre, you don't have this problem. If you don't put it in, this is a problem. It's like I pointed out, that root system is going to mass around each one of those outlets on the drippers. And to bring that point home, this is a vineyard. There's the drip line. You can see the roots mass down that drip line because that's where the water source, that's where the food source is. In this system, if you put in this system, it has been run for years and it hasn't stopped up because every 60 days they put the trifluralin in. Again, it's 1 ounce per acre. You're making a golf ball size area right around that dripper that roots chemically won't grow into, and you can prevent this from happening. The mistake that most people make is they do their September work, and then they get their last cutting off the second week of October, then they put the system to sleep. And the 1st of November, it runs out, and then we don't get a freeze until December, and that root system stays active, that wetted ball is collapsing because the plant is still using that moisture, and the roots go right back to the drip. So after the last one, the 1st of November, go back, do it again. 1st of February, go back, do it again. But keep the trifluralin in there every 6 months. Rusty pointed out manganese. That's what it looks like in the dripper. If you look initially at the water sample, it showed that we didn't have a problem. If you think about the dynamics that goes on with the drip system, you take water that's not under pressure in the formation, you bring it out, you pressurize it, you run it through the dripper, it shows you what the flow path looked like before, and stuff becomes unstable. And we actually started precipitating out this manganese. The system's already able to be cleaned up. It would have helped to have known that we had this as a problem before we started. That's what the back of the drip. This system was completely stopped up. And it's back running like it's supposed to now, and we're putting chemicals in to keep this from happening. Iron. We don't have a lot of it up here, but there are places where we do have iron. There's 2 problems with iron, as there's 2 problems with manganese. You have your elemental problem from the ferric iron, and you also have the iron bacteria. The bacteria is what causes that red film or slime. In the same way with manganese, it's that black film. And there's ways to handle it. And I'm not going to say it's easy to clean up, but it can be cleaned up. Know this problem occurs before there's going to occur before you do it, and treat for it. It's a lot cheaper to keep it from happening, especially if I have to do it. Now the other trick is, Rusty gave a great presentation on filtration. If your filter is flushing all the time, it's doing it for a reason. Taking the discs or the screens out of your filter is not the answer to a filter that's not. And if you do that, this is what you end up with. Sandpaper. Chemical. If you're going to inject any of the chemicals I've mentioned, and there's a lot more out there that you can use, make sure, A, that it is labeled for that, and you're following the label recommendations and regulations on that label. This product was not labeled for drip irrigation. It had been at one time, they lost the label. He said, well shoot, they did it before, I'll do it again. And it wasn't the chemical itself, it was the carrier that actually congealed in the water. This one was hard, we got it cleaned up. But again, if you just paid attention up front, stayed on the label, you wouldn't have this as an issue. We haven't had that problem so much here, but over in New Mexico, we have a huge problem with mold crickets. For some reason, they like to get and run little bitty holes in the sides of the tape. And the same product that we're using over there now for insect control of the crops solves this problem too. This is our big nemesis on the high plains of Texas, the pocket gopher. They love to chew, they have to chew on stuff to keep their teeth from getting too long. And very polyethylene is like chewing gum to them. They just absolutely love this stuff. We've tried a lot of different things. It turns out that a lot of the insecticides we use, if they don't kill them, they at least keep them off the tape because of the smell. a lot of the chemicals have such a bad odor. And these are really pretty clean animals, and they don't like to be muddy, and they don't like this stink any more than we do. And you don't generally see these problems during the growing season. It's once you shut down that you see the problem. Now, one of the things that we've been working, kind of like the Navy used to do with porpoises, we've been working on coming up with some way that we can correct the problem. So far, this hasn't been real successful. And you pointed out pressure relief. All of the systems I put in now are actually automated. The drip system turns on the wells and it turns off the wells. So I've got high pressure switches that will turn them off. Before this happened in August on a corn crop, and this used to be 6-inch pipe. But the power blinked and the drip system shut off and the well came right back on. And the valves had already started to close, and when the water, when it hit water hammered, and this was 40 feet of 6-inch pipe. Didn't have the picture with me of what it did to the filter station, but if you've ever seen Schedule 40 pipe exploded, this was not a fun day. Rusty also pointed out flush valves, and a lot of people say, well, my water's pretty clean, I don't need to flush those that often. This system is really clean. This is the second time this year that at the end of the season that I'm going to flush this out. But if you think about what our aquifer looks like, we don't have just sand and just gravel. We have striations of silts, clays. It's not a homogeneous thing. In a drip system, I don't need to filter silts and I don't need to filter clays because those are small enough particles to go through the drip system. But again, if you think about it, as I move further away from my supply line, my velocities, because every tank I'm pulling water off, I get my velocity so slow at the other end that all this stuff now, it decreases below the suspension velocity of a particular product and it starts to settle that stuff out. And it does the same thing going the other way in the tanks. So you're going to have a buildup, an accumulation of these silts and clays and products, even some fine sand grains that will build up in that tank and in the pipelines. And if you don't have a way to clean it out, I don't put a system in and I don't put out clean outs on the sub-mains, main lines, and flush valves for exactly that reason right there. Because that was, again, that had been cleaned out in May, and this I did in September. If you do it right, you're ready to hit a home run.